Nitrogen gas will not be evolved upon reaction of HNO2 with which of the following amines? Primary amine form alcohol with nitrous acid. Nitrogen gas with brisk effervescence is eliminated and clear solution is obtained, which is not so in the case of secondary and tertiary amine. So in primary amine reacts with HNO2, it will give alcohol and nitrogen gas. And in secondary amine, this is N-nitrosodialkylamine. N-nitrosodialkylamine is formed. And in tertiary amine, with reaction of HNO2 will give trialkyl amine nitrate, which is RNH plus NO2 minus, which on heating gives an alcohol and nitrosoamine, which is R2N. So option D is the correct answer. So when ethyl cyanide reacts with X gives propanaldehyde. The compound X is. It is a Stephens reaction in which CH3CH2C triple bond N in presence of HCl will give CH3CH2C triple bond NH plus Cl minus, which on further reaction with SnCl2 in HCl will give CH3 plus SnCl6 2 minus, which on boiling and hydration will give propanaldehyde. This is the mechanism of Stephens reaction plus ammonium chloride is formed. So option A is the correct answer. Dye test can be used to distinguish A. ethylamine and acetamide, B. ethylamine and aniline, C. urea and acetamide, D. methylamine and ethylamine. So dye test is given by aromatic primary amines and not by aliphatic amine. Aniline gives diazonium chloride with nitrous acid at 0 degree, which form colored dye with phenols. This is di-TsPO. Aliphatic amines form alcohol with evolution of nitrogen on treating with nitrous acid. So option B is the correct answer. Activation of benzene ring in aniline can be decreased by treating with A. dilute HCl, B. ethyl alcohol, C. acetic acid, D. acetyl chloride. The activating effect of the amino group is reduced by acetylation. The acetyl group being electron withdrawing effect, the lone pair of electrons of nitrogen atom towards itself. So it attracts the nitrogen atom lone pair towards itself, the acetyl group. So option D is the correct answer. The correct sequence of reaction to convert para-nitrophenol into quinol gives it involves A. reduction, diazotization and hydrolysis, B. hydrolysis, diazotization and reduction, C. hydrolysis, reduction and diazotization, D. diazotization, reduction and hydrolysis. So reaction of para-nitrophenol with Sn in presence of HCl, that is reduction, it gives alcohol and NO2 which on reaction with nitrous acid will give diazophenol, which on hydrolysis in presence of water will give quinol. So option A, reduction, diazotization, hydrolysis is the correct sequence. Which of the following is soluble in sodium hydroxide, that is in base? It is the second step of Hinsberg test, which is given by primary amine only. So when benzene sulfonyl chloride, the structure of benzene sulfonyl chloride is this: SO2Cl plus primary amine RNH2 reacts, it gives N-alkyl sulfonamide. N-alkyl sulfonamide has structure of benzene ring with SO2 NRH plus HCl. This is the precipitate N-alkyl sulfonamide. So when this react with base NaOH, it gives soluble benzene SO2 NNAR. So option A is the correct answer, where R is the alkyl group. The correct order of basicity of which of the following compound is? So of the following compound we have to find the basicity. The relative basic structure of primary, secondary and tertiary amine depend upon the nature of the alkyl group attached to it. So when alkyl group is methyl, the basic strength is R2NH, RNH2, R3N, then ammonia. When it is ethyl, it is R2NH, RNH2, ammonia, then quaternary. When it is CH, dimethyl, the order is RNH2, ammonia, R2NH, then R3N. And when the tertiary carbon with 3-methyl is attached, the order is ammonia, then primary amine, secondary amine, then tertiary amine. So here the order will be tertiary amine, then 3, 2 and then 4 imide, option B. When benzene reacts with HNO3 and H2SO4, there is an intermediate, and which intermediate reacts with SnHCl and heat to give. The relative structure of benzene reacts with HNO3 and H2SO4, which is nitrating mixture, to give nitrobenzene, which on reaction with SnHCl and heat gives aniline. So option B is the correct answer. Indicate which nitrogen compound among the following would undergo Hofmann's reaction, that is reaction with bromine and strong KOH to furnish the primary amine. Hofmann degradation of amide, that is RCONH2 plus bromine plus 4KOH will give primary amine plus 2 KBr plus K2CO3 and water as the product. So option C is the correct answer, which is used as a reactant. Parachloroaniline and anilinium hydrochloride can be distinguished by A. Sandmeyer reaction, B. NaHCO3, C. AgNO3, D. carbamyl test. With NaOH CO3 NH3Cl plus NaHCO3 will give aniline plus carbon dioxide, NaCl and water. So anilinium hydroxide is an acid salt and liberates carbon dioxide from NaHCO3, but parachloroaniline is basic and not acidic. It does not liberate carbon dioxide. And with AgNO3, anilinium hydrochloride plus AgNO3 will give white PPT of AgCl. Parachloroaniline does not contain ionic chlorine, so it does not give white PPT with AgNO3. So option B and C both are correct answer. In the reaction, 2X plus B2H6 will give the product. The amines X is R. Small amines such as ammonia or primary amine, that is methylamine and ethylamine, give unsymmetrical cleavage of diborane. This is diborane. So diborane, when reacts with ammonia, it will give the following structure. Large amines such as tertiary amine gives symmetrical cleavage of diborane according to the following reaction. So the symmetrical cleavage will be B2H6 plus 2NCH3 thrice. So all the amines, smaller amines, will react with diborane to give this cleavage. So A, B, C are correct answer. Foul smelling compound formed during carbamyl reaction is A, alcohol, B, aldehyde, C, alkyl isocyanate, D, carboxylic acid. So on heating with CHCl3, that is chloroform, with ethanolic KOH and primary amine, isocyanate is formed and is readily detected by offensive odor. This is known as carbamylene test. So when chloroform with potassium hydroxide plus primary amine on heating gives RNC, which is alkyl isocyanate, will give foul smell plus 3KCl plus water. So option C is the correct answer. In amines, the hybridization state of nitrogen is A, sp, B, sp2, C, sp3, D, sp2d. It is a similar manner of ammonia, except hydrogen is replaced by alkyl group. Since ammonia has 5 plus 3 divided by 2 is equal to 4, that is sp3 hybridization. Hence primary amine also has sp3 hybridization. Among the following, which one does not act as an intermediate in Hofmann's rearrangement? So Hofmann's rearrangement reaction is RCNH2 plus bromine plus KOH will give RCONHBr. So we have to find which of the following not intermediate. Plus KBr plus water. So the reaction goes, this is the first step of the reaction. The second step is RCONHBr plus KOH will give RNCO plus KBr plus water. And the third step of the reaction is RNCO plus KOH will give primary amine plus K2CO3. So these are the steps. So option RNCO is formed RCON is formed and RCONHBMR is formed in this reaction. The RNC isocyanide is not the intermediate of the reaction, so option D is the correct answer. Aniline reacts with which of these to form Schiff base? A. Acetic acid, B. Benzaldehyde, C. Acetone, D. Ammonia. Aniline reacts with benzaldehyde and forms Schiff base. Benzaldehyde is an aldehyde which reacts with the aniline to form benzyl aniline. So Schiff base is benzyl aniline. The reaction goes as C6H5NH2 plus CHO C6H5. On heating, there is removal of water molecule and benzylidene aniline is formed, that is C6H5N double bond CH C6H5 Schiff's base. So option B is the correct answer. Aniline is a set of reaction yielded a product D. So we have to find what is D. So when aniline reacts with NaNH2 and HCl, the compound A is formed. So A is diazonium benzene salt, which on reaction with CuCN gives B. So B is benzene cyanide, which on reaction with hydrogen and nickel to give compound C. So C is benzene attached to a methylamine. C on reaction with HNO2, that is nitrous acid, will give benzene methyl alcohol. So option D is the correct answer. Among the following compound, the least basic compound is C6H5NH2 is least basic compound due to resonance, by which lone pair of nitrogen takes part in resonance, and due to unavailability of lone pair of nitrogen, aniline becomes less basic. The lone pair of nitrogen is delocalized into benzene ring by the resonance, as NH2. The lone pair of nitrogen goes from benzene ring and there is delocalization and 4 resonating structures are formed. So option D is the correct answer. Azo dye is prepared by coupling of phenol and A. diazonium chloride, B. orthonitroaniline, C. benzoic acid, D. chlorobenzene. So when azo dye is prepared by coupling of phenol and diazonium chloride, the reaction goes as aniline reacts with nitrous acid to form diazonium chloride, which on reaction with phenol coupling of in weakly alkaline medium, the product will be para-hydroxyazobenzene. So this is the product, para-hydroxyazobenzene. So diazochloride is reacted with phenol, option A. Aniline on treatment with concentrated HNO3 and H2SO4 mixture yields A. ortho and para-nitroaniline, B. meta-nitroaniline, C. a black tarry matter, D. no reaction. So when aniline reacts with nitrating mixture, that is HNO3 and H2SO4, there will be formation of black mass. Nitration of aniline without protecting the amino group is not possible because HNO3 is strong oxidizing agent which oxidizes aniline, so forms black mass, option C. Aniline reacts with alkyl halide to give A. amino compound, B. tertiary compound, C. quaternary ammonium compound, D. azomethane. So when aniline reacts with methyl chloride, it forms NHCH3 attached to benzene plus CH3Cl, which on further reaction there will be replacement of another hydrogen atom by methyl group, so CH3C2. So this is tertiary amine, which on reaction further will give quaternary ammonium salt. So option C is the correct answer. Aniline on treatment with excess of bromine water gives. So when aniline reacts with bromine water in excess, it gives 2,4,6 tribromoaniline. So option D is the correct answer. Amino group is ortho-para directing for aromatic electrophilic substitution on nitration of aniline. A good amount of meta-nitroaniline obtained. This is due to A. In nitration mixture, ortho-para activity of amino group is completely lost. B. Amino becomes ammonium, which is meta-directing. C. Amino becomes NHSO4, which is meta-directing. D. Amino becomes NH minus NO2 plus, which is meta-directing. So on direct nitration of aniline, lone pair of electron present on nitrogen will accept a proton from the nitrating mixture to form anilinium ion. The anilinium ion is CH3C plus, which is meta-directing. So option B is the correct answer. Which of the following nitro compound, when treated with nitrous acid followed by treatment with alkali, produces blue color? So nitro compound attached to secondary carbon atom will give pseudonitrile. With nitrous acid, which on further treatment with alkali gives blue color. So the reaction goes as, which on reaction with nitrous acid will give CH3C, CH3, NO2, NO, which on reaction with alkali will give blue color. So option C is the correct answer. The end product of the reaction is, so when ethyl amine reacts with HNO2 nitrous acid, it gives ethyl alcohol, which on reaction with PCl5 will give B. So there is replacement of hydroxyl group by chloride, so it forms C2H5Cl, which on reaction with ammonia to gives compound C, which is ethylamine, C2H5NH2. So option B is the correct answer. Identify Z in the series. So when methyl cyanide CH3CN reacts with sodium and ethyl alcohol, reduction takes place to form X. So the X is ethylamine, CH3CH2NH2, which on reaction with nitrous acid will give compound Y. So Y will be ethyl alcohol, CH3CH2OH. So Y on reaction with K2Cr2O7 and H2SO4 will give acid. Oxidation takes place of alcohol to form acid. K2Cr2O7 is strong oxidizing agent to form acetic acid. Option C is the correct answer. The amine which can react with C6H5SO2Cl to form a product insoluble in alkali shall be A. Primary amine, B. Secondary, C. Tertiary, D. Both primary and secondary amine. So when C6H5SO2Cl is called as Hensberg's reagent, this reagent react with secondary amine to form a product insoluble in alkali. This reaction used to separate primary, secondary and tertiary amine from the mixture. So option B is the correct answer. Nitrobenzene on further excessive nitration gives. So when nitrobenzene with HNO3 and H2SO4. This is known as nitrating mixture. There will formation of meta-dinitrobenzene. So nitro groups is attached to meta position. So option B is the correct answer. N-butylamine, diethylamine and N-combined dimethylethylamine have the same molar mass. The increasing order of their boiling point is. So when primary amine, which is N-butylamine, secondary amine is diethylamine, and tertiary is ethyl dimethylamine. This is tertiary, secondary and primary. Primary amine have 2 hydrogen atom available for hydrogen bond formation, while secondary amine has 1 hydrogen atom for hydrogen bond formation, and tertiary do not have any hydrogen atom to form intermolecular association. Thus the order of boiling point for isomeric amine is primary, secondary and tertiary. So option A is the correct answer. Which of the following chemicals are used to manufacture methyl isocyanate that caused Bhopal gas tragedy? Methyl isocyanate industrially prepared by action of methylamine with phosgene. The reaction is CH3NH2 is methylamine with COCl2, which is phosgene. There is formation of CH3NHCOCl, which on heating forms methyl isocyanate CH3 N double bond C double bond O. So option C is the correct answer. Which of the following species does not exert a resonance effect? So when aniline reacts with H plus ion, it gives anilinium ion. Anilinium ion has structure of benzene ring attached to NH3 plus. Anilinium ion formed by aniline on accepting a proton is less resonance stabilized than aniline. Due to absence of lone pair in conjugation of double bond of benzene, it does not exert a resonance effect. So there will be no other resonating structure possible for anilinium ion. So option D is the correct answer.